All right, so this is going to be the video on variance and standard deviation for that probability density function. One of the really important things that I need to make sure that I am very clear about is before you do variance and standard deviation, you have to, and I mean have to, calculate the average. So in the last video, I found that the average, the expected value in this case was 3/8, which was 0.375. I have to have that value before I can move on and find variance and standard deviation. So now that I've said that, I'm going to go ahead and talk about how to calculate variance. Variance is very similar to calculating average. It's going to be like calculating a definite integral, but here's the thing. In this case, instead of multiplying by x, I'm going to multiply by x minus the average squared and then stick that next to my function. So this is going to be a little bit more difficult than the last one. Notice I'm using v of x, and this is actually a lowercase sigma squared. For the standard deviation, once you find the variance, it's going to be pretty straightforward. The standard deviation is the square root of variance. So if you got the variance, you're good to go, you're golden. Standard deviation is going to be really easy to find. Variance, it's going to be a little bit tricky right off the bat. So again, first thing you have to have is the average, which I have, 0.375. Now that I've got that written down, I'm going to go into my calculation. So again, since it's 0 otherwise, the only place that I have to worry about is between 0 and 1. So those are going to be my bounds of my definite integral. So from 0 to 1, again, I'm going to multiply by x minus my average. X minus my average was 0.375. Square it. Then multiply by my function. So 3/8 times 1 minus x squared. Okay? So now that I've got all that written down, I'm ready to go ahead and start trying to calculate. Now, hopefully things you were paying attention to is x minus 0.375 squared. So what I'm going to do is I'm going to go ahead and FOIL that out and try to get the answer. So if I do just simple math in my head, I'm going to do x squared minus 0.75x. And I don't know, that should be 9 over 64. What is 9 over 64? Big long number. Plus 0.140625. That's what happens if I take 0.375 and I square it. Then I've got that, what we have already done many times is 3/2 minus 3/2 x squared. This is going to be lots of multiplication. All right, you ready? Here we go. So I'm going to do all of this multiplied together. So I'm going to end up doing 3/2 x squared. I'm also going to do that times 3/2, 0.75 times 3 over 2 gives me 9 over 8. So minus 9 over 8x. Then I'm going to do that, 3 over 2 times, that was 9 over 64. I remember that. It's in my head. 9 over 64 gives me plus 27 over 128. So I multiplied all this times that 3/2, and it's basically going to look the same, only different exponents and negatives this time. So this is going to be minus 3 over 2x to the 4th plus 9 over 8x to the 3rd plus 27 over 128x squared. I'm going to go ahead and combine that 3/2 and that 27 over 128. Just because they're both x squareds, it'll make my life a little bit simpler. I'm also going to rearrange these so it's in a more normal order. Again, we're still calculating the definite integral from 0 to 1. So here I go. I'm writing it down here at the bottom. So that is going to be negative 3/2 x to the 4th. Again, I'm just taking care of putting it in order. Then I'm going to go ahead and do my x cubed, so 9 over 8 x cubed. Then I've got my combined x squareds was 219 over 128 x squared minus 9/8x plus 127, just 27 over 128 dx. Now that I've got all that done, notice it's a lot of fractions, but I can go ahead and start going into my integration process. So here I'm going to go ahead and perform the integration. So that's going to become x to the 5th, so I'm going to divide by 5, so it's going to be negative 3 over 10. That's going to be x to the 4th, so it's going to be 9 over 8 times 4, which should be 32, plus, and I'm going to run out of room, I have a feeling, That's going to become x cubed. So I'm going to make sure 219 divided by 3, it does simplify. So that's actually 73 over 128 minus what's going to become x squared. So it's 9 over 16 plus 27 over 128x. Now, again, I told you I was going to run out of room. I almost did right there at the edge. Again, we're going to evaluate that from 0 to 1. Hopefully you guys are getting used to the fact that I don't really need to plug in the 0. It's not going to be all that important. That's going to be 0, 0, 0, 0, 0. They're all 0. So all I have to do is plug in the 1, which makes them all essentially themselves. So it's negative 3 over 10 plus 9 over 32 plus 73 over 128 minus 9 over 16 plus 27 over 128. So all I have to do is just do that math. And so I'm going to do negative 3 over 10 plus 9 over 32 plus 73 over 128 minus 9 over 16 plus 27 over 128, and I get 1/5, which is 0.2. Now, it's kind of crazy that I did all of this crazy little math just to get such a nice, pretty answer in the end, but that is really what happens a lot of times with the variance, is it's just a math-intensive formula. But once you get down to it, you get a nice, pretty answer. The only thing I still have left to do is actually calculate my standard deviation. Again, remember, as I said before, if you look up here at the top, the standard deviation is the square root of the variance. So all I have to do to get the standard deviation is to square root 0.2. I know it's not going to be a pretty answer, but I'm going to go ahead and do it anyways. It gave me the square root of 5 over 5 is the exact answer, but it's approximately 0.4472135955. So there's my standard deviation. It's about 0.44. Now, let me make sure I say this one time real quickly. The standard deviation and the variance are describing the spread of my distribution. It's saying that normally, if my average is 0.375, I'm not going to vary too much by, in this case, 0.4472135955. It's going to be pretty realistic. One of the things I know you guys learned in Algebra 2 and probably redid in statistics was you talked about the 68, 95, 99.7 rule, also known as the empirical rule. Remember what that says is, if it's a normal distribution, it's going to generally be pretty close to 0.375, and it's going to vary by this much, by 0.4472135955. Now, I'm going to make sure I mention, if you watched the video on the box plot, you realize that this is not a normal distribution. It's not symmetric. It's skewed it's skewed to the right. It's skewed in one direction, so it's not going to exactly be 68% in between 0.447 of 0.375, but it's going to be somewhere near there. It's going to be probably about 50% in there, give or take. It's not going to be exact. But hopefully that does help you understand this a little bit better. Again, variance and standard deviation are describing the spread around my average over here. Hopefully, again, that helps. If you have any questions, don't hesitate to ask me. This is, again, statistical information. We're in calculus. Hopefully, if you don't remember this, if you don't understand this, just ask. I'm always happy to help.